Our last speaker will be Alessandro Gambale. He's a CEO and co-founder of Buildwind, an engineering company assisting city planners and building designers to create healthier, safer, and more sustainable urban environments through their expertise on CFD simulations applied on cities. So Alessandro previously obtained his master's degree in aerospace engineering from La Sapienza University, and during his career he also conducted extensive research in fluid dynamics and combustion at the von Karman Institute from 2005 to 2010, and thereafter at the University of Mons from 2010 to 2014. And so today he will give a talk about AI and CFD for smart cities.
Thank you.
I will give you the floor.
Wish me luck. Here we go. Okay, good afternoon, everyone. So this is the title of my presentation. We'll talk about smart cities and clean air. And I'll show you a couple of projects we've been working on, my company Buildwind, and how to put together air quality assessment and smart cities. So Buildwind is a small company based in Brussels. We specialize in simulations, computer simulations of cities and buildings. We basically create digital models and tools to predict wind, temperature, energy in buildings and cities. And the ambition of the company is to contribute creating better cities and better buildings, meaning safer, healthier, and more sustainable. So air quality is one of our fields of expertise, the prediction and assessment of air quality through numerical simulation. So first of all, let me say a few things about air quality. When we speak about air quality, we typically refer to pollutant concentration that is either measured or predicted, assessed somehow, and how that relates to some existing standards. So there's a number of standards and recommendations. What I'm showing here is the one from the WHO. So this is recommendations. It's not a standard. Then there is a European standard that is implemented sooner or later by each European country. So what we do is we compare concentrations of pollutants with a standard. That is the way we define air quality. Typically, different concentrations for the various pollutants are combined together in some sort of air quality index. So this is an example of how we do it in Belgium. Other countries do basically the same with small differences. There is a number of air quality stations around the country. In Brussels, in the Brussels capital region, we have about 15, exactly 15, if I'm not wrong, measuring some pollutants. For the most part, we measure nitrogen oxides in Brussels and PM 2.5. And then depending on the station, we measure also other pollutants like ozone and CO. And then this is mixed with models. So when we see those pollutant maps, the one that I'm showing on the right is for Brussels, for example. That is the result of a combination of measurements and models. So measurements is done in 15 air quality stations. Not even all of the municipalities in the region of Brussels have an air quality station. So for the rest, it's the result of models. So of course, the better the model and the better the prediction of the concentration of pollutants. So to give you an idea here, what I'm writing here is the resolution of those maps, best case scenario. Here I measure about 100 meter, but Brussels environment tells me that we're about 250 meter resolution, spatial resolution in Brussels. So it's much larger, of course, in areas that are outside the major cities. So we found that there were limitations in the existing ways that air quality is assessed in cities. This is not only for Brussels or for Belgium. This applies to basically all European cities and not only, with a few exceptions. So the number one limitation is the low spatial resolution, which means that best case scenario, with the help of a model, we go down to, say, about 100 meters, which means a building block. So not even one building, but several buildings or several streets together. And we have one value of expected concentration of pollutants for each of those big areas. So this is, of course, a limitation. The second limitation is the fact that those models that are used for the assessment of air quality make strong assumptions. And this limits the way they can predict future situations or any sort of change of implementation of policies, anything else, and how to predict what the impact would be on the air quality according to that. And then the last part is the lack of integration with any other city service. And so, which means that you can now download an app and have an idea of the air quality in the city. You can go on the internet, but this doesn't interact with anything else. So you have a separate app to go from place A to place B, or to see the timetable of a train, or to access any other service from the city, but it is not linked anyhow with the air quality maps or anyway measurements. So we try to address some of those things. The first step was to increase the spatial resolution. So we found that the best way we could do that was to introduce more details about the complex wind flows that are occurring in the city. So the wind goes around buildings and streets, and of course there are local phenomena that are created that it's impossible to reproduce with the simplified models that are used today. So we said, being this our main field of expertise, if we introduce proper wind simulations with accurate 3D models of a city, including all buildings, structures, streets, etc., we will certainly increase the accuracy. So that was the basic idea. Of course, it comes at a cost. Then the second thing is that this limited ability to predict situations that are not the existing situation, and doing something that is more than just a mere extrapolation of historical data, requires having more physics in the model. And that's what we do with basing the foundations of our system is just governing equations. It's fundamental laws of physics, together with data, of course. But there is a strong part that is just solving governing equation, which means we are quite free in simulating situations that have nothing to do with what has been measured in the past. And for the lack of integration, we thought that as smart city platforms are developing, even in Brussels, especially in the city of Brussels, this would be the best way to make this data accessible and to make the interaction with other services easy and possible. So this is what we created. We created a software tool that is able to make assessment and predictions of urban air quality, showing great imagination. We called it the Urban Air Simulator. Yeah. So we start with a 3D model of buildings and terrain of a city, building structures, everything. We're lucky enough to have a very good model in the region of Brussels, very detailed, one of the best that we know in the world, for once. Then we have data from weather stations. In our case, it's the airport. There are two main weather stations in Brussels. There's one in Nucle, the Meteorological Institute, and then there is the airport. So those wind data provide the conditions of wind from many years ago. So there are extremely good and reliable data from the last 30 years that we've been using, so that we have to make sure that in our simulations, we recreate all possible wind conditions for wind direction and speed that occurred in the last year, so that we are able to predict any possible reasonably imaginable situation. Then we use that to generate a large database with computational fluid dynamics, so super detailed wind simulations in the whole city. And on top of that, and that is the trick we use to overcome the limits of the computational cost, we use a machine learning algorithm that learns from the data of the computational fluid dynamics, which means that those simulations that usually take many hours, or in some cases even days to run for one single situation, one single condition of wind direction and speed, they can be reproduced in a matter of seconds. Well, actually minutes. Let's make it minutes. Let's not exaggerate. So then we couple this model with the data that come from the air quality stations. In this case, for example, in Brussels, we use the data from the air quality stations in the city of Brussels. In the previous project we performed in collaboration with ULB University, we use air quality sensors placed in our pilot site in the Solbosch campus. So there is data from sensors that help us actually to recreate and estimate the sources of pollution. And then this is coupled with the machine learning model based on computational fluid dynamics. The result is maps of pollutant concentration very similar to those that we have now with the federal system in Belgium, for example, but much more accurate. That's the basic idea. So these are some of the main benefits. As I mentioned, the high spatial resolution, of course, it's the main one, which means you can identify single buildings or a single playground or a single street, the cafe, and so be more specific about where and probably why the air quality at some locations is not good enough. And maybe think about possible mitigation strategies or solution, hopefully. The second thing is that we can account for the complex flow dynamics of the wind around buildings, which means that those simulations and those data can be used, hopefully, to improve the urban planning and the architectural design. Then, because we have physics embedded, so we have fundamental laws of physics in the model, then we can create scenarios that have not been measured. They never occurred, but we can simulate them better than some other models, at least. And then, for the integration, we thought that the best solution was to make the software available either as a standalone system, so you can look at that on the web easily, but also integrate it into Smart City or other city platforms very easily. So the results can be exported and then imported in any GIS system, basically. So it's open data, it's standard, there's no proprietary format, nothing like that. So the limitations, first of all, it takes a lot of computational resources, not much to run the model, but to generate the data, to generate the model. So the large number of simulations that must be performed to create the learning material is important. And that also means that this material must be generated again if there's any change, in particular in the geometry of the city. So any new building, any new green areas, everything that requires regenerating the entire material for the whole, at least, neighborhood, which is a considerable effort. When I say considerable, for the city of Brussels, it costs probably 10,000 euros and a few days. So it's considerable, not huge. Well, it depends on what you call huge. Then what I also want to mention, this is not a replacement for measurements of air quality. It's all the other way around. Actually, the better measurements we have, and hopefully maybe one day more measurements, more air quality stations, the better the prediction would be. This is a replacement for existing models that work on top of the measurements. So it's not a choice between measuring and modeling, it's a combination. So to give you an idea of the kind of resolution we have, this is an example from a previous project in collaboration, co-founded by Innoviris. Thank you, Innoviris. Co-founded. Yes, this is an example for that project. This is General Jacques. And to give you an idea, this is the resolution that we get. So you can really see the spots where you have accumulation of pollutants. Of course, these maps change in time. So we can then build statistics and see if there is something that happens half an hour per day or if it's a common situation. So what you can see, it's quite interesting, I think, is that even a street like General Jacques, which is not exactly probably the best place to breathe in the city, it's not as bad as it might be everywhere. So there are spots that are really red, so high concentration, but not everywhere, which means there are things that can probably be put in place to improve that. So this is the project that we're working on now. It's our first, say, large-scale project and real project, meaning it's beyond development. It's done for the city of Brussels. The city of Brussels has a nice program for smart city. They're planning to implement a number of services for citizens. So we won a call for project to develop this system and implement it into their smart city platform. The system is still in development. I'll show you just an image of what is the area that we are covering. So it's the whole Pentagon and part of the Northern District. So it's not the whole city of Brussels, unfortunately, but there's a part that is beyond the city of Brussels, on the other hand. We cover a surface of 5 kilometers square, so it's pretty big for this kind of simulations in great detail. You can see the image on the right. This is a slightly modified, but it's basically the regional model that we have. So the buildings are reproduced in great detail. So this is an example of what it will look like. The system is still in a testing and validation phase, so these are not final results, but this is a situation that you may have at some time during the day. So you have the concentration of various pollutants put together in the standard Belgian index for air quality, and you can go back in time. So there's a history, and you can click at each location and get the concentration, expected concentration of pollutants. So to conclude, I will speak about some of the opportunities that we see for the future development. Some of those are already being developed by us, and some of them are maybe possible, but require, of course, they require other things, including other modeling. For example, here I mentioned traffic. So the number one thing is the accessibility. Once you have a knowledge of the air quality in such detail, I think, first of all, there is much more interest from the citizens to be aware of that. And then also by the administration, they might easily think about some solution, hopefully think that was the purpose, of course, of the project. And it's quite easy to read data like that. When you have squares of 300 meters, which is the case now, it's really difficult to think about solutions. But when you have such a great detail, it's quite easy to think in which building to place, a daycare, for example, or where to place your outdoor area for a cafe or a restaurant. Just pick the best available area. This is without mentioning strategies to reduce pollution, but just to reduce exposure. So this is the same that can be done by each citizen. Once you have an accurate enough map of the concentration of pollutants in each street, you can pick the best available route. That is a choice. You can choose where to bike or where to walk or where to have lunch according to the air quality that is predicted. Of course, the same goes to policy design. Once they have a better knowledge, they will probably have strong fundamentals to design better policies and maybe test them with the same system. And finally, because the main source of pollution, at least the one where we can act, is traffic in a city like Brussels, like in most cities. There is a way, of course, to couple a system like ours with a simulator of traffic, for example, and have sort of a simulation of the impact of different traffic management strategies, which is something that we hope maybe cities will do in the future. Thank you. This concludes my presentation.
Thank you very much. Anyone has a question? Yeah.
Thank you for your presentation. I had a question about your prediction of air quality. Is it real time?
Almost. So
okay, but because I was wondering, it depends on the weather, I guess. It depends a lot of...
Yeah, so the main limitation we have is actually the data from the air quality stations. So we cannot update, we could update it more frequently than they update the data from the air quality stations, but it wouldn't make much sense. So that is the first limit. And then that we need to have enough data to make a good estimate of the sources, the pollution sources. So we don't rely basically at all on models for traffic, etc. Just we have a basic prediction of that, but then we fix it according to what is measured by the air quality station. So if we had more frequent data from the air quality stations than we could, then there is another limit, which is the computational time that we have at the moment. We could increase it, of course, but now for us it takes about 5 to 10 minutes to generate a map. So we are now updating once an hour. We could update it twice an hour, but that's a limit at the moment.
And second question, why do you have to be so accurate? What is the added value of having better accuracy? Which kind of decision you can take? Okay, you mentioned where to go for a restaurant, but I don't think it justifies such a effort
Well,
of computation?
if you're a real estate developer, yes, it does. Because if you're trying to sell or to rent a space for an outdoor restaurant and then it stinks, believe me, it does make a difference.
Yeah, but do you really need your model? I mean, you could put a sensor in the proximity if you want to make this kind of...
Yes, you can. You put it there for 30 years and you have your statistics. But if you put it there for 2 weeks, it's hard to measure anything that is really...
Again, how to believe your model? I mean, it's
because it's been validated.
Okay.
On data from 1 year with sensors.
Such the degree of granularity, such resolution. I mean, can you validate without sensors? I mean, I understand very well you're doing the best you can for what you have.
So the validation.
But I was wondering if it's such an accuracy, it's really important.
So several questions. The validation's been done on the Salzburg campus with several sensors. We have about, I think, 15 in the whole in a small area, of course. The campus and around it. So some of the sensors are, for example, on General Jacques. And so we validated in terms of concentration, in terms of also, we were also measuring wind speed, etc. And the predictions were within the uncertainty of the measurement. So that's good enough validation. Of course, unfortunately, we cannot validate properly in the city of Brussels because we don't have enough sensors. That's clear. So what the need for such resolution, spatial resolution, this is an example, the use of public space or private space, could be the restaurant, could be the playground, etc. Where to take the air when they're designing a building, for example. Sometimes there are big differences in between one side and another side of the building. Where to put green areas, because green areas are nice, everybody likes them, but they also have the impact of slowing down the wind. In some cases, it would be better to place them in a different location so that the beneficial impact of diluting the pollution is not lost. So there's a number of things that could be done.
Okay, thank you.
How can you evaluate the evolution of the quality of the air in 30 years if you can't evaluate also the evolution of the engine in 30 years?
I cannot evaluate in 30 years. We look at statistics 30 years in the past to predict what are the possible wind conditions far from the city, and then this gives the number of conditions, the types of condition of wind conditions that we have to simulate to generate a database.
Taking in consideration the evolution of the techniques, of the engine techniques?
No, just for the wind. Okay. Not talking about the sources. We don't make any major assumption on the sources, on the level of pollution from cars. We take them from the measurements of the air quality station.
A practical question, because you mentioned several times the smart city platform. So I was just wondering, what is this kind of smart city platform? Who is managing it? Because I had a lot of projects that I mentioned previously where we generated data or we use data, but they've never been centralized in a same place. Those data are distributed all over the places. So this smart city platform, what's that?
So the only one that I'm aware of in Brussels or in Belgium, actually. No, there's another one in Antwerp. They also have one. So the only municipality in Brussels that has a real project for smart cities with something already in place is the city of Brussels. So they do have this online thing, which is basically it's a GIS system where they would put locations of different interest and then in the future include all sorts of data. And services, but yes, it's a real thing.
Because I knew that Paradigm as this project of centralizing or trying to provide, but I don't know if this is maintained by Paradigm.
No. So for reasons that, of course, belong to the way municipalities are organized, there's no regional smart city program or system in place. It belongs to the municipalities, which makes it, of course, you can imagine that some municipalities may have bigger resources, so they're moving faster than others. So the city of Brussels, as far as I don't know, maybe you have other information, but it's the only one that has a program in place since a while already and something already working. Yeah.
Good to know.
Yeah. So Paradigm is actually managing the data at a regional level. But that's all they're doing, which means that those data would then be used by the smart city platform or the city of Brussels. We are also using those data for the 3D models. Urbis, which is the 3D model of buildings and terrain, it's a regional model, and it's managed by Paradigm and others. Yeah.
Okay, thanks.
Yeah, you want Just, yes, I was saying to react on this. Indeed, the municipalities have their own smart city plans, which on which the region doesn't have anything to say. But there is, I think it was created like last year or maybe the year before, the Smart Regional Board. I don't know if you have heard of it. I think it's an initiative from Paradigm. And I was invited in this because I coordinate the Smart City mission at the regional level. And so I met also the Smart City team from Brussels, the city of Brussels. But I was thinking through the afternoon that I'm not sure there is an academic representatives in this board, in this Smart Regional Board. And this would be, I mean, like an opportunity, a golden opportunity to fill the gap between public sector and academic through this regional board. Maybe that would be an idea.
When they don't play golf.
Of course.
Here there is also a question.
One more technical question. The simulations you do to build your model, are they like LES runs or?
Runs.
Okay, yeah, figured. And so one second, I have no idea how it works because I'm completely ignorant. But like when you, I don't know, open your weather app on your phone, it gives you like an air quality map. I understand that your model is way more resolved than that you have, but is the numbers that you get from the two similar, or is it like, because I don't know how the ones you have on your weather apps, how they work, so.
So that depends on the app.
The iPhone weather app.
Yeah. I'm not sure where the Apple probably or Google where they take their data from. So there's a number of ways that can be done. The easiest way probably is to have satellite data because those are easily accessible from each and every one. Because each city has, of course, they all have air quality stations somewhere, and they all publish data, but the access, of course, not that easy. So I don't think that Apple or Google, they have an API to import data from Brussels or Antwerp or any other city. So what I believe they do, they just take satellite data to estimate pollution sources somehow, and then they mix them with meteorological data for wind direction, and then they have an equivalent roughness for city and vegetation, etc. It's pretty rough, and that's it. So the other models are more complex, like the one we have in Belgium, because they couple all of the available air quality stations with a model that is anyway already more advanced than what probably Apple can do. So I'm not sure you should trust the Apple thing. I don't know. Yeah.
Okay. No questions.
So, thank you very much. So what I propose now, thank you, Alessandro. Okay, so thanks again for these very nice presentations. Yeah, I think no, it's okay. It's just we have one chair more. No, there's Maida. So let's wait for Maida. But the way we are gonna work now is that I would like to have maybe an interaction with the audience and see if you have outstanding questions that you would like to discuss with the speakers. I had actually noted down, people have sent me already a few questions, so we can work. If you don't want to start with the question, I could start with a few of them and see who among the speakers, or maybe all of them, want to address them, and then I can give you the word for additional questions that you might have. Is there a problem? Okay, we just wait for Maida. Maybe to warm it up, I will start with the question that actually was sent to me by Emanuele. Right? Can I use? Too late. You wanna say it directly? Please. Okay, I will. Okay, smart cities, and I think this came out from many of the presentations. Also, I pointed out in the introduction, means a lot of things. So, what do you think are, in your opinion, the priorities that we should actually put forward for the Brussels region, And what do you think us as academia and public services, public servants and private sector should actually focus on? We want to start in this order?
Okay. So it works, yeah. So thank you for the question, Broads. Maybe, does it work?
Yeah.
Yeah. So maybe one way to answer this is to start from a point which was raised that technical solutions exist, but then they makes it hard to be implemented.
Mm-hmm.
And so maybe one question is how to, one way of thinking about, let's say, filling this gap, maybe is, how we, how we integrate the design and implementation phase. So one of the courses that I teach and I'm involved with my day-to-day work is change management. And one thing that you, change management in public administrations. And a key concept around which we try to, convey to our students is the idea that it is important to think the design, to think at the implementation all together with the design. And so to which extent the tool we develop are responding to a real need, to which extent those who are meant to be the recipients of the innovation are part of the design process. And so maybe one way maybe is to bring together, find the ways, governance, let's say, mechanisms to bring together the designers and the implementers. And so technical experts and the public administrations. And maybe another point is the issue of the skills. How do we bring these skills related to the IT sectors within an environment which it's used to function through bureaucratic norms?
Thank you. I don't know, you want to add anything on?
I continue more from my perspective.
Yes.
I mean, in terms of smart
which is the richness of this is that
which is a completely different perspective. So I have the feeling that what we need, if we want to add towards smart city, is a continuity of data availability. So which means an infrastructure, which means investments. So just having from time to time some website with 1 year of data of 2003 about bikings, I mean, it's not smart city, okay? Just to make prototype, just for us to have some fun, but if we want to make smart city, it's a serious question. The system is complex, so if we want to control it and make it better, it means investment. If we talk about mobility, the only who knows the real situation of mobility in Brussels are not from Brussels, are Google, are Waze. I mean, those guys really know how mobility is working. And we don't know, I guess, or we know just partially, or we depend on them. So I think if we want to make it serious, it's a question of putting a lot of money in infrastructure. Otherwise, it's just about the future. And so this is my personal view.
Yeah, and as the mic goes to you guys, I would like to add on this. So how serious is the problem that arises from the fact that we have delegated all this to these algorithm makers?
I think they put a lot of money, you know, but they don't put it in our pocket. But I think they spend an incredible amount of money for the consultants company like Deloitte. There has been a lot of press about it. The incredible quantity of, and I would say that the interesting projects to push further and to try to implement would be the one who are the most impactful, not only for the Brussels citizen, but also for the politician. Because if you look at about the elections in Brussels, you know, and we don't have a government yet, and I don't know if we will have one before 10 years, because when I know some of the people being involved in the discussion, it's just, there is no solution, you know, really. It's incredible, but there is no solution. But anyway, this is another problem. But mobility was one of the reasons why, for instance, the ecologist has lost a lot of votes, and also the party has lost a lot. And if you think about mobility, you obviously you have to mention Good Move, for instance. I think Good Move has a very nice intention. In fact, that was to make our air and to make us breathe better, etc. But they did it in the wrong way, you know, because they didn't, they didn't let the people having something to say. So they cut, and they didn't use any kind of software that Gianluca proposed. And so if mobility is one of the key, public good in Brussels, I think that this would be a good opportunity to make something different, collecting data, implementing software, consulting citizens, and pushing it further. I think another very interesting one is public health. For instance, when you have to take, when you want to make a radio, an IRM in Belgium, you have to go to different hospitals, and in order to find an appointment, where it would be so easy to have a central, ways of, and some of them have, but as you say, you mentioned in your talk that the problem of Brussels is that those many silos, and you want to try to cross those silos, but you realize that I think there is a lot of interesting initiative in Brussels, but people don't talk to each other. That is also related to the way the Brussels government and Brussels and Belgium is organized, make the frontier hard to cross. And but something like mobility should concern all. So I would push very much to mobility and public health, and energy transition is another one which where everyone would agree. Energy communities is a very interesting thing in order for the energy transition to move on. And there again, what is interesting in energy community, what I realize is that is local democracy. Yeah. Because when you create a community, you have to agree on how you're going to exchange the energy being produced by your neighbors. Yeah. So you have an exercise of local democracy, which is really nice to be done, because the people have to agree on. And once you agree on how the energy will be distributed, you can put a software in place in order just to respect what you have agreed on. So this is another very good example of a smart city type of thing. You have a mic.
Yes, I don't know if it works. Yes. Yeah. I agree totally with you, but I disagree that it isn't a political problem. You said it's another topic. To me, that's the topic, indeed. Because, as you said, there is, from my little experience now in the public sector, because before I was in the private, I can see there is concurrency. Is that a word in English? Yes. Concurrency between the public administrations. And at the beginning of my mission, I mean, Bruxelles Environnement didn't want to work with me. So I'm leading a climate mission. I cannot work without them. And it was my work to convince them to go forward with this mission. So to me, the problem is political. And with Brussels, we added layers and layers of authority levels, because we wanted to satisfy the Netherlands, the Dutch speakers, the French speakers, and so on. And we constructed little by little, but now today we have like a construction which is not understandable, and even less to the citizens.
Is it manageable?
No, no. I mean, I wish we will simplify this, but I don't really know. I don't have the answer how we are going to do so, because there are a lot of people engaged in these administrations. This is job. I mean, it's really, to me, a society issue.
They want to preserve their little power,
Yeah, that's political. I mean.
Yeah. So. Thinking from an academic perspective, right, and very much like very many things that have been said. So the data coherence, or the data making sense of all the pieces of data we have, right? So this is maybe something we could very much contribute to from an academic perspective. I very much liked also what you said about the implementation, this kind of internal debate you have, right? And in academia, we have also the problem, for research funding, oftentimes we cannot think about applied projects, right? So there is, sometimes we can, but maybe, this is something to reflect upon, right? And I'm thinking also about what you were saying about the integration, and oftentimes we think about separated areas of problematics that are very focused, given, again, the funding schemes we reply to, right? But when we think about real situations, thinking about projects where we can integrate different layers of, say, air quality and mobility, or air quality and population, land use, I don't know, many aspects we could think about in synergy, right? So this is, I think, an exercise to do also, like from a funding scheme perspective, for what is it that we can really aim for from academia, no? But I do think that the data coherence and thinking about our potential contribution through interfaces, maybe that could be read applicable to municipalities, and we can start having a more present role in real political discussions with tools that they can understand and they can play with, right? Because right now there are many research projects, but oftentimes their translation to reality doesn't feel so obvious, maybe, to them.
Well, also the problem is probably political, but I don't think in terms of smart cities we have a big problem in Brussels or in Belgium. I think what it takes to make smart cities is data. We have good data, lots of data actually, open data also, could be better, but most cases, most of other cities are worse actually. Then I think it takes talents and ideas. There's no lack of talents and ideas, at least in Brussels. If you don't have that, you can still import them, no problem. So the last missing ingredient might be money to do it. So if you have money, you can buy talent. If you don't have money and you have talent, you don't do much. So when you think about developing smart cities, each city separately, even in the region of Brussels, I think it's just impossible. So that is probably, but unless you have enough money, then no problem. So I think that the risk of that is that they will end up, because those solutions will be needed, citizens will expect that. And so the problem is that if they don't have enough resources to develop their own solutions, they will end up buying some ready-made commercial solution, which will mean that somebody else will actually own the data or own the ability to use data. Because the problem with smart cities, like in many other applications, is that the amount of data, I didn't mention that even in our modest application, the amount of data that is generated is huge. So the city of Brussels is not able to manage on their platform the data we generate. We have to scale down the resolution. They're not able. So, and that's the city of Brussels. And it's only our data for air quality. No big thing. No history, not just the instantaneous air quality. It's too much. So which means the amount of data is huge. So if you have somebody else doing the smart city platform for you, they will end up owning the data, because even if you have the data, you don't have the ability to navigate them. So that's I think it's a big risk, and maybe we should consider putting together the municipalities and maybe even working with other regions, other cities. I mean, there's a fantastic work that they're doing in Antwerp for smart city applications. Do they talk to each other? Not so much. So that's maybe a good idea. I mean, it's a small city in a small country. If we don't get together, the risk is that they're gonna buy us out.
Thank you. I think the question on infrastructure is the point on infrastructure. I think it's a good one. Yesterday, I got some insight on the EIC, European Innovation Council meeting that was held in Brussels. They were discussing the fact that we got behind, indeed, with the infrastructure in general, not only in Brussels and in Belgium, but in Europe. And we need to regain a little bit independence on, with respect to other big powers, like the US, given the consideration that we have now. So I think that's indeed a very good point. But I had maybe a contradictory point on this one. This was also something that I received by a few people. So all these algorithms are very data hungry. What is at a certain point, and we also work, in similar things, we always face this huge, massive amount of data. We say that these algorithms have to be, these are data intensive. They are, and we need to have this massive capacity of looking at this data. But what is the limit? Because at a certain point, how do we define usefulness with respect to the data that we have, and what is the limit with respect, to what we really need, and not just wasting energy and computing time? Or I don't know, and this can be picked up by any of you if you.
Well, I can tell you what we do. What we do is that we try to store the minimum possible amount of data. That's the first thing we do, which means that in some cases, the resolution that you need, especially to store historical data, for example, for air quality, is not the highest possible resolution because you don't need that. Our simulations, they go down to a resolution of 30 centimeters. That is necessary to solve the equations, but not to store data because that would be huge. So that's the first thing we do. And then the second thing is that the use of techniques like the machine learning algorithm that actually avoids most of the computational cost, which also means, of course, memory to store data and energy and then pollution, etc. So there are smarter ways of doing things that actually go in the right direction. But yes, it's still a massive amount of data. Yeah.
I'd like to just say a little thing here because we've heard a lot of projects which were very intensive on data, but because I'm an old AI guy, I might say that not all AI and not all algorithmic development has to do with data and machine learning. Some of the projects I've shown was not at all with the. For instance, if you think about Parcoursup, which is a very simple algorithm, there's no data involved in that. Obviously, you can use data in order to assess the success of those algorithms and the impact of those algorithms. The design of the algorithm that didn't need any data. Like if you think about ways, or you think about the first type of itinerary algorithm, they didn't need a lot of data. It was just trying to find a good road. Or once you take into account the traffic, obviously data come into play. But I mean, you can do a lot. When we organized the vaccination cockpit, we used very few data. There was just an optimization problem. Which vaccine you have to distribute. So I guess a lot of problems that Brussels has to face, and indeed, for instance, finding a government is not a real data problem. It's just putting some intelligence in good algorithm and running this algorithm, testing things, simulate. Obviously, you can do a lot of simulation with our understanding of reality, and you don't always need so much data. I agree with you that for assessing the quality of air or assessing the mobility of the situation of mobility in Brussels, then data would be welcome. But in order to take the right decision, you can do a lot of things without too much data too. Don't think that all AI is about collecting data and running deep learning or whatever in order to find the solution for that. Just a little parenthesis from a good old-fashioned AI practitioner.
Someone who did neural networks before the hype.
Yeah, I did neural networks in the 80s. So.
Any other reaction on this?
I think that there is, in any case, sometimes an obsession for accuracy. And so this idea of the limit of the data. So at the end, the goal of an algorithm is not to make a prediction, is to make a decision. And the decision is not just the accuracy of the precision, is also of the prediction, but also I have an idea of what is the usefulness, the cost. So making a decision is more than making a prediction. And sometimes we strive for having 1% more accuracy, but in any case, we have no idea of the cost of making one decision instead of the other. So I think we should be aware that at the end, the model should not be exact, it should be useful. And of course, and the most difficult part, in my opinion, nowadays, of course, you can add tons and tons of data for gaining 1%, but at the end, you don't know really what is useful. So I think it's important to understand that the final goal of all that should be to have decisions which are useful for someone, and what Hugues was saying before, the involvement of citizens, and understand really what they want. I mean, it's 1% more of accuracy really what they want. I'm not sure. They would like some quality of life. So I think there is sometimes too much an obsession for accuracy without enough assessment of what really we are looking for. And data in that sense is not the answer, because not having huge amount of data, you answer the question, is more understanding the problem we are dealing with, which goes beyond probably our role as well.
So all models are wrong, but some are useful.
Yeah, this was the idea.
Okay, so now I would like to see if there are, I don't know if there was any other reaction on this. Otherwise, I mean, I have other questions, but I would like to give you the opportunity to ask. Yes, there is one there. Wait a second that the mic will reach you. I have an algorithm that will send it to you. It's analogical.
Also, I would like to extend the topic of data accessibility. So, Maida and I will try to run a transportation simulation, and we might need a data set from the private company, which will cost like thousands of euro. So, I have a master's in television, and I don't know if you know Dr. Cobell Thomas. He is one of the co-authors of the data format, the CTGML in digital twin. And he has some project with BMW and Audi to train their auto driving system in digital twin. And they have very detailed like city 3D models. Like they have all the trees, they have all the street lamp, they have all the like the walls and the texture and the window and the color of the pavement, like so that they can they can train the AI in that digital system. So what I want to ask if so we all know that data are very expensive and hard to access. Do you think it is a challenge for us if maybe because it is so expensive, maybe we need to invest more for private company and academia, we need to invest more in profitable project rather than some important project like public house. Do you think it is a challenge, or like it is also a chance that it means our study could be very profitable?
You have the mic.
So what is true nowadays that most of the technique we are using are useless if you don't have valuable data. So and it's true at the very same times that the owner of the data most of the time realize the importance of them, and so they make you pay for their value, or they prefer to keep inside their data because they know that there is value on this data set. On the other side, I think that without realistic data, it's very hard to have an advance of science, because otherwise it's more about simulation hypotheses which are useful, but at the end of the day we want to do something which has an impact on reality. So I don't have the answer. What is strange is that most of those data are produced by the public, the general public. So all data of mobility, why should they belong to Google while they are produced by all of us? Data about environment. So I think it's also a responsibility of the state, of the public government, in somewhat pretending to have access to those data. It was the case during COVID. There was a lot of data which were owned by private companies, for instance. At the time, there was interest in knowing about transactions to understand if people there were making their shopping from home instead of moving. So or data about telecom, so which were providing a lot of information about where people are in the town. And this, indeed, at that moment, all the data were useful for making decisions about lockdown, and it was very hard at the time to take advantage of those data. So I think there should be some sort of procedure where, for public interest, all those data, which at the end of the day are produced by humans, by the society, should be used for the sake of society. But yeah, I think we are quite far from that. People, on the contrary, realize that data are very useful, and they are very jealous now. And it's much harder now to collaborate and have access to real data than 10 years ago. The only thing I can say.
Yeah, just to move on, just a little point, but you made an important point about profitability, and the economists made a big difference they make a big difference between private goods and public goods. Normally, the public goods, we should be out of the market things, and then this is the reason why the public, they finance the public goods, and because they are out of the market. But you're right in saying that most of the public goods are being privatized, and data is, as Gianluca was nicely saying, data is so much important to optimize our public goods, and the data are being owned by a lot of private companies, and they want to deal with our public goods themselves. They want to care for public health, they want to care for mobility, they want to care for even university access, they want to take over about all the public goods. So this is a very strange moment. You can see what happened in the United States. Everything seems to be more and more privatized. So, and I think academia has an important role to play here, because Emmanuel was telling, you try to train and convince our next students to be much more involved in the, because we have to resist this privatization, because it doesn't make sense, that mobility belong to Google, or, the public health, or the corona alert, whatever belong to Google, the way the smart meter in our home belong to Google, etc., etc. We have to resist this tendency and not play this game, so not play the profitability game. Because if we play the profitability game, we're trying to adopt the strategy. We have to get out of it and resist that. Public goods are public goods. Access to school, access to public health, have a nice mobility, have a nice air. That is public goods. This is a different thing but private. We don't have to pay for getting a nice air, or or reaching a place from A to B in the fastest way. We shouldn't pay for that. This is my philosophical moment.
Par exemple, dans la publicité, si quelqu'un fait une publicité dans la rue et filme ma maison, je peux lui demander des droits sur le fait qu'il ait filmé ma maison. Est-ce que les autorités publiques ne pourraient pas demander des droits du fait que, parce que les datas, c'est pas les leurs, c'est les nôtres, c'est ma maison. Et appuyer avec les autorités publiques, on pourrait dire, vous avez le droit de l'utiliser, mais c'est un droit que vous allez payer.
On a abdiqué à ça.
Parce que c'est la même chose que le droit d'auteur dans un livre, quelque part. Pardon, j'ai switché en français. Désolé, c'était plus facile pour moi de l'exprimer en français.
Anyone wants to react on that question? Yeah.
Yes, just maybe I was thinking from what you just said, a lever to this issue would be, to my opinion, public policies, because I'm thinking also like a big difference I faced when I switched from private to public sector is that you cannot do what you want. I mean, I found private companies that seem incredible in my domain that I would contact to engage collaboration. I can't do that in the public sector. You have to go through public procurement and so on. And this is really a limit to this collaboration. So I think, yeah, public policies could be a lever. I don't have the solution, but it's an idea.
So maybe one thing to react about that is that initiative, how it was taught far at the beginning, and I can tell you I'm also involved in initiative in other sectors. It's exactly to create this kind of bridges, so to create frameworks that are permanent with the public administration, where there is a continuous dialogue and not a one-off event. So probably that's one of the things we should try to push more, so to have these places, these conventions that are there, that are permanent and that allow dialogue.
I see in many eyes cocktail, but let's finish with the last question.
Yeah, I just wanted to ask you that, so we are talking about the fact that these smart cities can be helpful for the quality of life of people. There is something like maybe, air pollution is quite easy to measure in a way. So there's a quantitative estimate, I reduce pollution, and so I increase the quality of life of people. But there are also something that it's much more difficult to evaluate in a quantitative way. I don't know if you have any idea on how to go about that.
So we can assess the impact on the on social justice, on quality of life.
Sorry for the hard last question.
What I can say is that I don't have the answer, like it's the answer or the solution, but I know that the European Commission, for example, have developed a set of indicators, but from social to well-being to really mathematical indicators, also really numbers. But it's, from my understanding, it's a field to explore. It's not. I mean, the profit-driven opinion is the main one, and I don't know if it answers your question, but that's something to be explored. I think it's not so much developed yet.
No, maybe is to go back to a point which was raised before about how to create a connection with the public administrations. I think that this is a quite new, at least from a public bureaucracy, to think about how to get engaged with this type of issues. And this is something that maybe we should construct all together. And in this sense, I invite you to intervene in the master we're setting up with the ULB. I think this is something which is in the making, and maybe this is a space that you should join. This is what I feel to say.
That's what I wanted to say.
Yeah.
There is an incredible turnover so in the public administration, so it's hard to keep someone, because they change a lot, and so because also the politics is influencing a lot who is managing the public administration. You may have a good interlocutor, and then the elections come and he disappears.
That's another point. We speak of digital policy, but what about of digital politics? I mean, how do we, as long as I see the public debate, there is no clear opinion about who should own the infrastructure, the IT infrastructure, who own the clouds,
the data.
The data. I mean, this is something that I think also political representative democracy is not ready to this debate yet. There is civil society, like the coding, the collective coding you were mentioning. But what about? I mean, we still live in representative democracies, and political parties are not putting forward ideas in this sense. And so I think there is also an issue concerning not only the public administrations, but the readiness of the political elites to bring forward these discussions about the political economy, I would say, of the ICT infrastructure.
Okay, I think it's a very perfect closure. So thank you very much.